On the floor of the Mediterranean Sea, in the cold and perfect darkness 3,500 meters below the surface, a particle arrived from somewhere in the universe. It did not come from our solar system. It did not come from our galaxy. It came from somewhere out there. From a source so violent, so extreme, that it accelerated a single particle to an energy 30 times greater than anything ever detected. When it hit, it produced a single flash of pale blue light, invisible to every fish swimming nearby. Registered by a single string of glass spheres on the ocean floor that nobody had finished building yet. Scientists did not notice it had happened for over a year. And now, in June 2026, they are still arguing about where it came from. Welcome to Exophiles. The particle is called a neutrino. And neutrinos are perhaps the strangest, most elusive objects in the universe. In this video, I want to take you through the whole story. What neutrinos are and why they are almost impossible to catch. What the KM3 net detector is and how it works. What happened on February 13th, 2023, and what the numbers actually mean. Then the three competing theories for where this particle came from, each one more extraordinary than the last, and none of them confirmed. One theory involves monstrous black holes firing beams of matter across billions of light years directly at Earth. Another involves the first black holes born in the Big Bang, slowly evaporating across 13.8 billion years and finally dying in a burst of radiation. A third involves dark matter, the invisible substance that makes up most of the universe's mass, decaying into particles for the first time. None of them is ruled out. None is confirmed. This is what science looks like at the edge of the known universe. Neutrinos are subatomic particles, smaller than atoms, protons, or electrons. They have almost no mass, no electric charge. They interact with almost nothing. Right now, approximately 100 billion neutrinos are passing through every square centimeter of your body every second. They come from the sun. They pass through you from above, through your skull, your chest, and your feet. You feel nothing. They do nothing. A neutrino could pass through a wall of lead 1 light year thick and have a greater than even chance of coming out the other side. This property, this almost total immunity to interaction, is what makes neutrinos so valuable. They travel through the universe completely unimpeded. To catch a neutrino, you need an enormous detector. When one occasionally hits an atom, it produces a particle moving faster than light in that medium. That rule applies to light in a vacuum. In water or ice, light slows down. When it happens, the particle produces a flash of blue light. The KM3 net detector is built on this principle. A 3D array of glass spheres anchored to the Mediterranean floor. The water itself is the detector. On February 13, 2023, a neutrino entered the sea near Sicily. It hit a water molecule just outside the detector, producing a high-energy muon. The light was recorded. The data was stored. When the analysis was completed in early 2024, they estimated the energy, 220 PeV. PeV stands for petaelectron-volt. The Large Hadron Collider can accelerate protons to about 0.0065 PeV. KM3-230213A carried 33,000 times more energy. Something in a distant galaxy accelerated this particle to a record energy and sent it on a journey to Earth. What that something is where the debate begins. Theory 1. Blazars. A supermassive black hole with a relativistic jet pointed at Earth. These are among the most powerful accelerators in the universe. Theory 2. A primordial black hole explosion. Hawking predicted black holes evaporate. In the final moments, they release all remaining energy in a burst. Theory 3. Dark matter decay. It would mean the particle was born in the first second of the universe and released when a dark matter particle finally decayed. The full KM3 NET array, when complete, will be far more sensitive and may finally resolve the debate. That is the universe at the edge of the extreme. Subscribe to Exophiles for the full picture. Drop a comment. Which theory do you think is right? See you in the next one.